Picture the exact coordinates of one of the most photographed buildings on Earth, but rewind the clock to 1994. There is nothing there. No island, no rock shelf, no sandbar breaking the surface. Just 280 meters of open Arabian Gulf water, marked only by a handful of floating buoys bobbing in the current. No crane, no barge, no worker has touched this spot yet, because there is nothing solid to stand on. And yet, within 5 years, a 321-meter tower will rise from that exact patch of sea, floating on land that human beings built from scratch. One pile, 1 ton of sand, 1 bolt at a time. This is not a story about a hotel. It is a story about how you build a foundation for a skyscraper in a place where the ground itself does not exist. And it starts, unbelievably, with dropping a hammer into empty water. The first physical transformation happened at the waterline. Instead of trying to build the hotel directly from floating platforms, engineers created an artificial island beneath it. Rock was brought in and placed around the planned perimeter, forming a protective boundary that could contain the material used to build the island. But simply dumping rock into the sea was not enough. The perimeter had to be shaped carefully, so waves would not continuously wash material away. Large armor rocks were positioned around the outside edge, creating a breakwater that acted as the island's first defense against the Gulf. Inside that protective ring, layers of material could gradually be placed and compacted until the island began to emerge above the surrounding water. Survey teams constantly checked elevations and positions, while heavy marine equipment moved material into precise locations. What looked from a distance like a pile of rocks was actually becoming a carefully engineered platform. The island had to be stable enough to support enormous construction equipment during the years ahead, while also remaining strong enough to resist the repeated impact of waves and currents. Only after this artificial ground had been established could the project move toward the far more demanding task of anchoring the tower itself. Creating the island solved only one problem. It gave the workers somewhere to stand. It did not give the tower a foundation strong enough to carry its enormous loads. Beneath the artificial island was still seabed material, and engineers could not simply place a massive concrete slab on top and expect the tower to remain stable. Instead, the foundation had to reach deep into the ground below the island. This is where the project shifted from marine construction to deep foundation engineering. Large drilling equipment was positioned over the future tower footprint, and reinforced concrete piles were driven or installed deep into the underlying ground. These piles acted like long structural legs extending below the artificial island. Their purpose was to transfer the weight and forces of the building deeper into stronger layers of soil and rock. The pile locations had to be extremely precise because the tower's structural system would eventually depend on their combined performance. Workers were not simply making holes and filling them with concrete. They were creating a 3-dimensional underground support system capable of resisting not only the downward weight of the hotel, but also the enormous lateral forces produced by wind, acting on a structure more than 300 meters tall. Once the deep piles were installed, the next challenge was connecting them into a single structural foundation. A collection of individual piles could not simply be left standing independently beneath the building. Their loads had to be collected and distributed through a massive reinforced concrete foundation system. Workers formed reinforcement cages, positioned steel reinforcement around the pile heads, and prepared the area for large-scale concrete placement. Concrete was then poured and consolidated to create the foundation elements that would connect the underground piles to the structure above. This stage was critical because the tower would experience forces from several directions at once. Its weight would push downward, while wind would try to push the structure sideways and create overturning forces. The foundation, therefore, had to work as one integrated system rather than a collection of separate supports. Every connection between pile and foundation mattered. Reinforcing steel was arranged to provide the tensile capacity that concrete alone could not provide, while the concrete created the mass and compressive strength needed to distribute forces through the foundation. Slowly, the invisible skeleton beneath the future hotel was taking shape, turning a man-made island into a true structural base. With the deep foundation established, construction could finally begin moving vertically. The central core became one of the most important elements of the tower because it would provide a major portion of the building's stiffness and stability. Reinforced concrete was constructed upward in carefully controlled stages, with formwork repeatedly positioned, reinforced, filled with concrete, and moved higher as the structure climbed. At ground level, the process looked relatively ordinary, but the difficulty increased with every new level. Materials had to be transported upward, reinforcement had to be positioned accurately, and each newly completed section had to connect precisely with the structure below it. The core was not simply an elevator shaft hidden inside the hotel. It was part of the building's structural backbone. As it rose, it established the vertical reference around which other structural components would be assembled. Engineers had to maintain alignment throughout the climb, because even small positional errors could become significant as the height increased. Floor after floor, the concrete core extended farther above the artificial island, transforming what had started as a marine foundation project into the beginning of one of Dubai's most recognizable structures. As the central structure climbed, engineers began building the system that would give the tower its distinctive shape. The Burj Al Arab was not designed as a simple rectangular high-rise. Its structural geometry had to accommodate the sweeping sail-like form that would eventually define the building. Large structural members were therefore installed around the core, creating the framework that would support the floors and exterior systems. Reinforced concrete and steel components had to work together, with connections carefully engineered to transfer forces between them. Cranes lifted major structural elements into position, while crews secured them at progressively higher elevations. Each completed level became a temporary working platform for the next stage, allowing the construction team to continue the vertical climb. At this point, the building began to reveal its unusual geometry. Instead of rising as a conventional box, the structure expanded and shifted according to the architectural design, creating increasingly complicated loads on the central structure and foundation below. The higher the building became, the more important every structural connection became, because the tower now had to behave as one continuous system from its uppermost sections all the way down to the deep piles beneath the artificial island. The most recognizable part of the Burj Al Arab required a completely different level of construction precision. The giant external frame that creates the hotel's sail profile had to be assembled around the main building while maintaining its sweeping geometry. Massive structural members were lifted into position by cranes and temporarily supported until permanent connections could be completed. Workers operated high above the water, assembling the frame piece by piece according to carefully surveyed coordinates. The frame had to remain stable during construction even before the entire structural system was complete, which meant temporary supports and carefully planned installation sequences were essential. As more sections were connected, the enormous outline of the sail gradually appeared against the sky. The structure was doing more than creating an architectural silhouette. It was becoming an engineered system capable of carrying the loads associated with the building's unusual shape and supporting the exterior envelope that would later cover it. From the ground, each newly installed section might have looked like another piece of steel, but together, those pieces were creating the defining structural form that made the project fundamentally different from an ordinary skyscraper. Once the major structural frame was established, construction shifted toward enclosing the building. The exterior could not simply be treated like a conventional glass curtain wall because the Burj Al Arab's shape created large areas and complex transitions that had to be carefully coordinated with the structure. Exterior framing, cladding systems, glazing, and specialized fabric elements were installed progressively as the tower continued toward completion. Large sections had to be lifted, aligned, and secured to the structural frame. The exterior system had to withstand wind, heat, sunlight, and the harsh marine environment, while also maintaining the building's distinctive appearance. The famous white exterior surfaces were assembled around the structural skeleton, while the large triangular spaces between the main structural elements were prepared for their specialized envelope systems. This was another stage where construction accuracy mattered enormously. The exterior pieces were not independent decorations. They were attached to a structure that could move slightly under wind and temperature changes. Connections, therefore, had to accommodate the building's behavior while keeping the envelope secure. Layer by layer, the exposed structural skeleton was transformed into the recognizable sail-shaped building seen from Dubai's coastline. With the main exterior form taking shape, workers could begin transforming the structural shell into an operating hotel. One of the most demanding interior spaces was the enormous atrium, which rises through a huge portion of the building and creates the dramatic vertical void visible from inside. Constructing this space required coordination between the structural frame, floors, stairs, elevators, mechanical systems, and architectural finishes. Crews installed floor structures and connected them to the main structural system while leaving the central atrium open through multiple levels. At the same time, electrical, plumbing, ventilation, fire protection, and other building services had to be routed through spaces that had been planned into the structure long before the finished rooms existed. This meant the project was no longer just about making the tower stand. It was now about fitting an enormous amount of infrastructure into a complex three-dimensional structure without interfering with its primary load-bearing systems. Mechanical and electrical crews worked alongside structural and architectural teams, installing systems behind walls, ceilings, floors, and service spaces. The empty structural frame was gradually becoming a functioning building from the inside out. The closer the project came to completion, the more construction became a battle of coordination. Every hotel room, corridor, service area, elevator, restaurant, and mechanical space required multiple systems to operate together. Plumbing lines had to connect throughout the tower. Electrical systems had to distribute power. Ventilation equipment had to move conditioned air, and fire protection systems had to cover the entire structure. Elevators and vertical transportation systems were installed within the central core, allowing people and materials to move through a building that now stretched hundreds of meters above the sea. Interior crews followed behind the mechanical installations, enclosing systems behind finished surfaces and constructing the rooms around them. The unusual geometry created additional challenges because not every floor had the same shape or dimensions. Spaces near the outer edges had to be fitted around the building's distinctive structural form, while service systems had to remain accessible for maintenance. Construction therefore progressed in layers: structure first, services next, then partitions, finishes, fixtures, and equipment. The closer each space came to completion, the less visible the engineering became, but behind every finished surface was a network of systems that had been carefully integrated into the original structural design. Before the building could be considered finished, the construction team had to prove that all of these systems worked together. The foundation had to perform as designed, the structural frame had to remain stable, the exterior had to withstand its environment, and the building services had to operate across hundreds of meters of vertical height. Engineers inspected structural connections, tested mechanical and electrical equipment, checked water and fire protection systems, and verified the performance of elevators and other critical infrastructure. The building's location added another constant factor: the Arabian Gulf. Wind, salt, heat, humidity, and waves were not temporary construction problems. They would continue attacking the structure for decades after the workers left. That meant materials, protective systems, joints, and exterior components all had to be checked before completion. Construction crews moved through the building correcting defects, finishing incomplete areas, and testing equipment repeatedly. What had started years earlier as an artificial island surrounded by open water was now a complete vertical structure, but the final stage was about proving that every individual component, from the deepest foundation pile to the highest exterior element, could operate as part of one enormous engineered system. The final transformation is what makes the entire construction process so remarkable. At the beginning, there was nothing beneath the future hotel except seawater and seabed. Engineers first created the protected artificial island, then built deep foundations through it, connected those foundations into a massive structural base, and began raising the central concrete structure. Around that backbone, they assembled the steel framework that produced the sail-shaped profile, enclosed it with specialized exterior systems, and gradually filled the structure with the mechanical, electrical, transportation, and interior systems required to operate a modern hotel. Every stage depended on the one before it. The island had to survive before the foundation could be built. The foundation had to be complete before the tower could rise. The structural frame had to be stable before the exterior could be installed. And the building envelope had to be secure before the interior could be completed. That sequence is the real story of the Burj Al Arab's construction. Engineers did not simply place a skyscraper in the ocean. They first manufactured the ground, anchored that ground to a deep foundation system, built a structural skeleton hundreds of meters into the sky, and then wrapped an entire working hotel around it. What began as open water was transformed, step by step, into one of the world's most recognizable engineered structures.